going to talk about temperature measurement. And really, it's pretty straightforward. We know that in America, we measure things in degrees Fahrenheit. And we know that at atmospheric pressure, from 32 degrees Fahrenheit, where I create ice, all the way up to 212 degrees is where I would boil water. However, this is a relative temperature scale. Degrees Fahrenheit is relative. And it was relative to whatever Mr. Fahrenheit wanted it to be. So he said when at atmospheric pressure, what he was doing, he saw ice being formed at 32 degrees when you were removing energy to that ice. And he created the scale. And 180 degrees later, he saw steam if he raised the energy of that water. So that's a relative temperature scale. See, temperature is a measure of the random molecular kinetic energy of a substance. Random molecular kinetic energy. So when you rub your hands together and cause friction, if your hands get hot, you're increasing the molecular kinetic energy. Well, this is a relative scale. When does all of that kinetic energy stop? That would be absolute zero. And we find out that it occurs at minus 460 degrees Fahrenheit, is known as absolute zero. This is where all kinetic energy stops. There is no molecular kinetic energy. It is dead in the water. That is an absolute scale. That means at that 0 degrees all the way up to 460 degrees was essentially not really taken into account with Fahrenheit because he started at 32 degrees Fahrenheit. So here's the deal. Sometimes it's useful for me to convert from relative scale to an absolute scale. The scale that we care about is the Rankine scale. Rankine, right? And this is important because you'll notice we have a knowledge requirement here. K102. We need to recognize the difference between absolute and relative temperature scales. The relative scale, Fahrenheit or even Celsius, they were relative to when we saw ice melt, essentially at atmospheric pressure, and steam being formed at atmospheric pressure. So they're very relative. It was an empirically established points. Well, when we do the measurements and we just started taking all of the energy out of, say, water at atmospheric pressure, we saw that at minus 460 degrees, boom, all molecular kinetic energy stopped. So I need to be able to convert between absolute and relative. So the relative, if I want degrees Rankine, it's equal to, well, degrees Fahrenheit plus 460. That's how you convert. Such that if you had 80 degree water, to convert it to degrees Rankine, you would add 460, and we would have 540 degrees Rankine water. This would be the absolute temperature of 80 degree water. It is essentially saying here is absolute zero. Here is another point that we call 0 degrees Fahrenheit, 0 degrees Rankine, and the distance between the two is 460. So if you're up here at 80 degrees, that'd be 80 degrees relative to this point. I want it relative to this point. So I need to add that distance in, or 540 degrees Rankine, or 80 degrees Fahrenheit. We can also convert between Celsius and Rankine. Celsius, obviously, not something we in the United States have adopted very much, but this is how we convert the two. It's on your equation sheet for the NRC. If you want to convert between the two, you'll see that Fahrenheit is equal to 9/5 times whatever the Celsius is plus 32. So when you're driving by the bank and it says it's 20 degrees Celsius, if you want to know what that is in terms of Fahrenheit, you need to multiply it times 9/5 and add 32. I typically just double it and add 30. So I know it would be about 72 degrees. Also on your equation sheet, if you want to determine what Celsius is, it is equal to 5/9 times degrees Fahrenheit minus 32. So these are on your equation sheet, and they're not that difficult. Very important, though, these relative temperature scales on the right-hand side of this relative temperature scales, a knowledge requirement here. Absolute temperature. You'll see where water freezes at 32 degrees, 0 degrees on the Celsius scale. We see it go all the way up, and water boils at 212. I should be able to convert between the two. But on a relative temperature scale, you'll see that there's Rankine and Fahrenheit scales right here. And look, minus 460 degrees is 0 degrees Rankine. I'd have to, if I wanted to start at 0 degrees Fahrenheit, that's equal to 460 degrees Rankine. Water boils at 212 degrees, but if I add 460 to that, it actually boils at 672 degrees Rankine. Very key. When we're doing thermodynamic problems, when we want to determine cyclic efficiency, we must use an absolute scale. Must use Rankine.